Hello everyone, welcome back to SISYA class channel, and once again as promised I am back with the new chapters, and that is tails by dots and lines, right? So this was my promise to you. I fulfilled your promise. Now what you have to do, watch till the end. Tails by dots and lines, everything I'll cover in very detail, right? So in short, if I'll tell you what I am gonna cover in this chapter, so basically this chapter is all about finding means and medians, and reading the line graphs. Okay, so in your previous classes all of you knows that how to find the mean and medians, right? But what is different in this chapter? So basically in this chapter we will cover the mean and median, that is fine, but on number lines through graphs, how will you find the mean and median? That is the concept that I'm gonna deliver today. Okay, so motivation is clear to you. So before starting the class, let me give you a brief intro about myself. And I am Dhananjay. I have done my masters in mathematics from NIT Durgapur, and I mainly take classes for the JEE. Okay, so all of you knows what you have to do. Please visit the SISYA classes courses. See how many courses we have going on. First one is the booster courses right now, maths champ courses also, and the SISYA topper program. Please explore these courses. These are very interesting courses. Simply what you have to do, just visit the sisyaclass.com/LTC and tap on your grades. Fill the phone number and state name. That's it. And you can enjoy the 3 classes at rupees just 19 only. Okay. Let's see what we're gonna cover today. The first topic that I'm gonna take is the mean of as the balancing point of the data. Actually, balancing point, the meaning of balancing point is mean only. Okay. So the first topic is mean. Second is there any changes when we add, remove or scale some values in mean? We're gonna look at it. Third one is the median. We will do the same thing with median and try to observe that the values are changing or not. Clear? The fourth topic is solving for unknown values using mean. Next is the mean and median with some frequencies table will be given to you, and you have to find the mean and median. And at the end we will try to study the line graphs. Okay, how simply you can study the line graphs and how it is helpful in reading any graphs. Okay, so this is very important. One of the most important topic is line graphs and finding the mean and median for any graph. Okay, so this was the overview for this chapter. Let's start with what is mean and median for any graph. So all of you knows the mean is sum of all values divided by the number of values. Like sum of all values divided by the number of observations. If you trying to say sum of all observation divided by number of observation, and mainly it represents the center of any data, right? Center of any data. Median, in short, if I'll tell, median is when you will arrange it in ascending order. Any data, when you will arrange it in ascending order, the middlemost value is the median, right? And if 2 middle values exist, just take their average. That will be the median. I'll explain through an example, don't worry. So mainly in this chapter we will look for mean and median, but on the number line with the help of graph. Clear? So let's take any 2 numbers. The first one is 3 and 7. And if I have to find the mean of 3 and 7, what I'll do? Simple, no? Simple, just add 3 and 7. What is the meaning of average? Add the 2 numbers, divide it by 2. So 3 plus 7 is 10 divided by 2. And that is 5. 5. So 5 is the mean for 3 and 7. Clear? What about 8 and 9? 8 and 9 will do the same thing, no? Add 8 and 9. Divide with 2. That is 17 upon 2. Don't worry. The mean can also be in fraction or decimal also. So 7 upon 2, that is 8 upon 5. Not upon 5. This is 8.5, right? So whenever you are given two numbers, all of you know how to find the mean of that numbers, right? Let's observe through a graph. So suppose we have, okay, so suppose we have a number line, okay, and the data is given in this way, right? Like this is 3, okay, 3, this one is 9, okay. So what is the median of 3, sorry, mean of 3 and 9? What is the mean of 3 and 9? Okay, some data is missing here. I think this is 3, okay, fine. This is 8, this is 9, okay. So suppose, okay, let me explain through a number line. Some examples I am giving you on number line. See here. So suppose you are given a dots here. Don't worry, some data is missing here, I think, in this example. No worries. Let me explain through another example. So suppose this is 2, this one is 3, this is 5, and this is 7. Fine. And the dots I am putting here. 2 dots here, 1 dot here, and 1 dot here. Okay. Now I have to find the mean of this. Mean of these numbers. How will you find it? So simple, no? You have to add all the numbers. So for 2, if you will see, we have 2 dots. So we will add 2 plus 2 plus 7. And how many observations we have? 1, 2 and 3. Means I have to divide with 3 as well. So 7 plus 2 is 9. 9 plus 2 is 11. 11 upon 2. That is 5.5 is the mean for this example. 5.5 is the mean for this example. Okay. So this example is clear to you. How will you find the mean for any numbers or any graphs when you will given in the form of dots? Okay, this was the basically the crux point of finding the two numbers through graph. Example I am giving you. Suppose if you have to find the mean for this graph, right? So this is 10, this is 12, this is 16, and this is 18, right? So how many observations we have? 1, 2, 3 and 4. So just add the total numbers. 10 plus 12 plus 16 plus 18. 10 plus 12 plus 16 plus 18. What is the sum of all these numbers? 10, 10, 40, 48, 48, 54 to 56, right? 56. That is 56. But how many observations we have? 1, 2, 3, 4, right? 1, 2, 3, 4. So you have to divide it with 4 also. So 56 divided by 4 is 14. So what is the mean? Mean for the first graph is 14. Simple, no? So whenever you are given any graph, just add the total numbers divided by the number of observation. Clear? So how many green dots we have total? 1, 2, 3, 4. What is the values here? 10, 12, 16, 18. So what I have done? I have added all the values divided by total number. So sum is 56 divided by 4. That is 14. Simple. So the mean is 14 here. Now can you find the mean for this one? This is 8. So what will be this number? See the pattern, no? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is something like 9, right? Between 8 and 10, this is 9. This is 11. Between 11 and, sorry, between 10 and 12. So this is 11. What about this number? This is 17, right? Add the three numbers 9, 11 and 17. What is the number you are getting? 9 plus 11 plus 17. So this is thus be 27, 28, 28 plus 9. 28 plus 9, 37. Yes, 37 divided by 3, right? Because the number of blue dots, how many blue dots we have total? See, 3. So you have to divide it by 3. Means average you are finding, no? So divided by total number of observations. So we have 3, this is approximately equals to 12.3, that's it. So this is the mean for the second graph. For the first graph it was 14. For the second graph it is 12.3. What about the third one? Third one is 2 plus 4 plus 10 divided by 3. This is 16 divided by 3, right? So approximately this is 5.3. Okay, so for the first graph, second graph, you understood how to find the mean. But what is the concept here? The concept is mean is the center of any data. Mean is the center of any data. What is the meaning of it? Let's observe it graphically. So see, when you will observe the first graph, the mean was 14, right? Okay, sir, mean was 14. So let's see the left hand side distance and the right hand side distance. Okay, so this is the 10, right? So what is the distance between 14 and 10? What is the distance between 14 and 10? So this is 4. Okay, sir, fine. Mean is 14. So left extremes, if you will see, it is 4. Right extremes, if you will see, again this is 4. But will I always get the same extremes? The mean always will be in between, yes or no? The total left hand side distance and right hand side distance will be always equal. But these extreme values will not be always in between. So the question is the mean always the midpoint of two extreme values? The answer is no. Because if you look at the, let's look at the second example. Okay, so what is the difference between 9 and 12.3? It's not equal to the difference between 12.3 and 17, right? This LHS distance and RHS distance are not equal here. So the extreme, if you will see, the mean is not always the midpoint of the two extremes. The two extremes here are 9 and 17, right? 9 and 17, and the distance we are not getting as equal. But the main point here is the left hand side distance and the right hand side distance, overall it will be equal. The left hand side distance and the right hand side distance, overall it will be equal. We will see later on. Okay, this one, this is called the balancing rule. The balancing rule says that the mean is the point where the total distance values on the left hand side will be equals to the total distance on the right hand side. Total distance on the left hand side, total distance on the right hand side. What is the meaning of this, sir? See, in this example, if you can see, what is the mean here? So this is 6, this is 7, this is 8. So 6 plus 7 plus 8 divided by 3. This will be the mean. Let's check it. What is the value we are getting? So 7 plus 7, 14, 14 plus 1, 15, 15, 6, 21, 21 divide 3, that is 7. Means the mean is 7. It's correct. Mean is 7, that is fine. But count the left hand side distance and count the right hand side distance. So if you will count it, this is 6 to 7, the distance is 1, right? From 6 to 7, the LHS distance is 1. Okay, sir. LHS distance is 1. What is the right hand side distance? Right hand side distance means 7 to 8. So from 7 to 8, right hand side distance is also 1. So overall the distance will be same in mean. So this is the point here it is written. The mean is the point where total distance of the values on the left equals to total distance on the right. Clear? Let's observe through one more example. Suppose we have this data given to us in terms of graph. Firstly, you have to find the mean for it. So what is the mean? So this is 2 plus 2, right? We have two dots here. So you have to take 2 double. So 2 plus 2 plus 8, right? 2 plus 2 plus 8. So how many data we have? 3. 3, number of observation is 3, so you have to divide it by 3, okay? So 8 plus 2 is 12, divided by 3 is 4. So the mean is 4, okay sir? Mean is 4 we have. Now let's count the overall distance, left hand side distance and the right hand side distance. So let's count it now. So left hand distance is 2 plus 2. 2 plus 2. From 2 to 4 we have 2 units, but we have 2 data given, no? We have 2 data, okay sir, fine. So we have to add 2 times, so 2 plus 2 is 4. Count the right hand side distance. What is the right hand side distance? From 4 to 8. What is the RHS here? From 4 to 8. From 4 to 8, again this is 8 minus 4, that is 4. So again we are getting the left hand side distance and the right hand side distance same. So this concept is clear to you. This is a balancing rule. The distance from the mean towards the left hand side and the distance of the mean from the right hand side of any given data on the number line will always be same. Okay. So this was all about the balancing rule of mean. Okay, now let's move ahead to the next topic, and that is, can there be more than one center? Okay, let's see through an example. So suppose we are given 10, 10, 11, 17. Data is given to us as 10, 10, 11, 17. If you find its mean, it will be 12. How? 10 plus 10 plus 10 plus 10. That is 40. 41, 48, if you will divide 48 with 4, that is 12. So mean is 12. Okay, clear? Now let's see if we will try to assume a different mean other than 12. I am saying that 12 is not mean, sir. Fine. If 12 is not mean, let's say 13 is the mean. Okay, sir. So 13 is the mean. So can 30 be a mean for this data? Can 30 be a mean for this data? The answer is no, because the distance on the LHS side, see, we have data 10, 10, 11, 11 and 17, right? 10, 10, 11 and 17. And I am telling you that can 13 be a mean? 12 is the mean. I am just countering my point that can 13 be a mean? So the answer is no, 13 cannot be a mean. What is the right hand side distance? First of all, check it. The right hand distance is 17 minus 13. What is 17 minus 13? 4. 17 minus 13 is 4 here. 17 minus 13 is 4. What about the distance of 13 from 10, 10 and 11? What is this distance? Let's count it overall. So this will be 3. 4, 10 to 13 it will be 3. Again from 10 to 13 it will be 3. So 3 plus 3 plus 2. So 3 just 3 2 just 6. 6 plus 2 is 8. So 8 not equals to 4, right? 8 is obviously not equals to 4. So 12 cannot be the, 13 cannot be the mean. So no numbers greater than 12 is the mean. In the same way, if I'll assume any number which is less than 12, suppose 11 I have assumed, still you will get the distance of LHS and RHS as different. But it should come equal, no? By balancing rule, the distance of the left hand side from the mean and the distance of the right hand side from the mean, it should be equal. So again here also LHS not equals to RHS. So 11 also cannot be the mean. So the only possibility is 12, that's it. 12 is the only possibility. So there cannot be more than one center. This is one and the unique point. Mean we are getting one and only unique point, and this is the only center for our data. So clear? So till now we were talking about the mean only, right? Now let's see what are the observations if we will try to add some values, if I will try to multiply some values in the data, if I will try to subtract some values from the data. So what is the total overall effect on the mean? Will it affect or not? Or if it will affect, how much there will be effect on the mean? Okay, let's find out. So we know that the mean is the point where total distance of the values on the left equals to the right hand side. That is the balancing rule. This statement is coming from the balancing rule. Okay, sir. See here, for this data, try to find out the mean you will get as 11. Let's check it how. This point is 5. This is 6. This one is 9. Okay, let me see. 8 to 12, no, this is 10, I think. Yes, this is 10. This is 12. This is 24. Okay, let's add it all. So 5 plus 6 plus 10 plus 24. So 4 data we have. So we have to divide it with 4. Right? Okay, sir. Add it. So 6 plus 5 is 11. 11 plus 10, 21. 21 plus 21, that is 42. 42, 3, 45. Oh, sorry, 44 divided by 4. The mean you are getting 11. The mean you are getting 11. Okay, that is fine. So the mean is 11. Okay, clear? Now, the point is, what if you will add a number greater than 11 in every numbers? Like if you will insert, not every number, if you will insert a number greater than the mean, like the mean you are getting as 11, that is fine. But what if I'll try to add a number greater than 11 in the same data, like 17 I have added here. Okay, sir. 17 I have added. So will there be any effect on the overall mean? Can you tell me, will there be any effect on the overall mean? Yes. The answer is yes. There will be some effect. If you will insert any number greater than the mean, the overall mean will increase. If you will insert any number less than the mean, the overall mean will decrease. See how? Just try to find out overall mean for this. If you will add 17 in this data, the overall mean will be 12.2. So the earlier it was 11, and all of you know how to find the mean. Just add all the values, and this time you have to divide with 1, 2, 3, 4, 5, right? Because one observation you had increased, new numbers you had inserted, 17. So this time you have to divide with 5, not 4. So be careful in this. So mean you are getting as 12.2. So you are increased with some values in mean, right? From 11 it jumped to 12.2. And why? Because you have inserted a number 17. So when you will insert it a number greater than mean, 17 is greater than 11, so overall mean increases. In the same way, if you will insert a number less than the mean, overall mean will decrease. If you will insert a value equal to the the mean always remains the same. This is the three conditions that we have. That's it. Including any number or inserting any number will affect the overall mean. Clear? Okay. So let's see, keeping the mean unchanged. Okay. Can we include or remove multiple values without changing the mean? What is the point of this, sir? Can we include or remove multiple values without changing the mean? The answer is yes. We can include or remove multiple values, but one thing you have to remember, and that is the total distance on the left hand side from the mean should be equals to the total distance on the right hand side. You have to balance this. The point that you are removing, you have to remove from both sides, from the left side of the mean, from the right hand side of the mean, and its distance from the mean should be equal. Overall distance should be equal. So see here, two values less than the mean plus one value greater than the mean. What I did, I have removed two values less than the mean and added. I have added two values less than the mean and one value is greater than the mean. Observe this graph. If you will observe it, the mean we were getting as 9, right? And all of you know how to find the mean. Just add the total values divided by the number of observations. So the mean was 9. Fine, sir. Now see, observe the green dots here. Green dots, three numbers we have included, right? 2 on the left hand side, yes, 2 on the left hand side and 1 on the right hand side. So what is the overall values on the left hand side? Are you able to visualize this? Left hand side में अगर मैं देखूं तो left hand side में total distance है 2 plus, see here, no, this is from 7 to, what was the mean? The mean was 9, right? So 7 to 9. 7 to 9. What is the distance here? 7 to 9. 7 to 9. Distance is 2. But we have two observation here. So you have to add 2 two times. So 2 plus 2 equals to 4. The mean was 9. The mean was 9 here. Basically this is the mean. This is the mean. And the left hand side distance is 4. The right hand side distance would also be 4, no? See, right hand side we had only 1 point. Let's check the distance. From 9 to, what is this point? Represent 13, right? Between 12 and 13 it is, between 12 and 14 it is 13, obviously. So distance between 9 to 13. What will be the distance between 9 to 13? Tell me first. 9 to 13, so 13 minus 9, that is 4. So overall it's balancing, right? Overall the value is balanced. So there is no change inside the mean. There is no change inside the means because we have removed the distances, no? The left hand side distance we have 4. Right hand side distance we have 4. So basically we are balancing it by removing. If I would have removed the distance with 5, there will be change in the mean. So if LHS equals to RHS, either you include some values or exclude some values, the overall effect on the mean is nothing, means no change in mean. No change in mean. This was the concept of keeping the mean unchanged. Understood, everybody? So either you can also add two values greater than mean and one value is less than mean. Obviously you can add it. So the key takeaway is the mean stay fixed only when the total distance added on each side of the mean is equal. This is what I was explaining. Just maintain the balance and you are good to go. So I hope this concept is clear to you when there will be no effect on the mean. Clear? Now let's see what happens when we add a fixed number to every value inside the mean. Previously we were just inserting any numbers, right? Now this time what I'll do, in every values I'll add some numbers. Okay sir, in every values if I'll add some numbers, observe this example. If you can observe it, this is 3, this one is 4, so this will be 5, this is 6, so this one will be 7, 8, 10, 12, 13. Just add the total values divided by number of observation, you will get mean equals to 7.18. Add it, no? 3 plus 4 plus 5. How will you add it? 3 plus 4 plus 5 plus 6 plus 7 plus 7 2 times. Because we have 2 dots here. 7 plus 7 2 times. 8 plus 8 2 times. Then 10 plus 13 divided by total number. When you are adding the total numbers, no, remember that we have 2 dots, so you have to count it 2 times. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide it by 10, you will get 7.18 as mean. Now the point is add 10 to every values. When you will add 10 to every values in this data. So observe 3. If you will observe 3, when you will add a number 10 to 3, it will shift towards 13, right? So the first point is 13. So the first one is 13. What about 4? 4 will be now converted into 14. 5 is 15. 6 is 16. 7 is 17. 8 is 18. 10 is 20. 13 is 23. Simple. This was all about adding any number. But what is the overall effect on the mean? So try to find the mean for this. 13 plus 14 plus 15 plus 16, 17 2 times, 18 2 times, 20 1 times, 23 1 times. Add, just divide with number of observation, you will get mean equals to 17.18. 17.18. So what you are observing here, from 7.18 to 17.18, overall we are adding 10 only, that's it. So whenever you are given some data, fine, and you are adding a same number to every data, overall there will be effect of same number on the mean. So mean was 7.18. Just add the numbers, that is 10. Overall number will be 17.18. How will you prove this one? Let's see the algebraic proof for this. So suppose we have n number of data, x1, x2, x3, xn. Okay, and its mean is a. Okay, see here I have written the proof, but let me explain it. Mean equals to a. Mean equals to a. What if I'll multiply with, if I'll add the 3 with all the numbers? Okay, you instead of 3 you can add any numbers, 1, 2, 3, 4, 5, 10. Let's say k also you can add, where k represents any number. So first of all let's add 3 and observe. So x1 plus 3, now it will be x2 plus 3, x3 plus 3, xn plus 3. So how will you find its mean? So obviously mean is just use the concept, no? Mean is add all the observation divided by total number of observation. So x1 plus 3 plus x2 plus 3 plus xn plus 3. xn plus 3. Add the like terms together. So x1 plus x2 plus xn, x1 plus x2 plus x, And one more important thing here, you have not divided it, no? So how many observations you have? X1 plus 3, x2 plus 3, dot dot dot, xn plus 3. So number of terms here is n, so you have to divide with n also. So x1 plus x2 plus dot 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 xn plus 3 plus 3 plus 3 plus 3, how many number of times? N number of times. So this is 3n divided by n, overall divided by n. So basically this is x1 plus x2 plus xn divided by n is mean, obviously. So this is mean, no? For n data, how will you find the mean? Add all the observation divided by number of observation. That was obviously the mean. So this value is a, and 3n plus 3n upon n. 3n upon n is 3. 3n upon n is 3. So what is the final result? Are you able to get it? Final result is a plus 3, means in mean, the original mean was a, and you have to add 3 to get the final mean. So directly add 3 in the previous mean, no? So the result is, whenever you have to add any fixed number to every value, just finally if you want to find the overall mean, in mean just add that fixed number, that's it. So 3 was not unique here, right? 3 is not unique, so instead of 3 just take any number k. So the overall mean will be a plus k, that's it. Because 3 was not unique number, no? In place of 3 take 4, 5, 6, any number you can take. Take k, k will be any real number. So it will be a plus k. This will be the overall effect on the mean. Clear? For subtraction also, obviously this will work. For subtraction also. Like we added 10 here na, to all the data. You can subtract 10 also. That is also fine. So finally in mean you have to subtract 10. Okay. So that's it. Enough discussion on this mean. Now let's come to what happens if we'll multiply with some constant inside every observation. Constant with some scalar number, basically I'm trying to say. What happens to the average if every value is the collection of the collection is doubled? Doubled means basically we are multiplying the collection with 2. Okay. If you will multiply with 2, no? See, this was the example of the previous one. Previous example. In this data, what I did, I multiplied with 2. So this was 3, this is 4, this is 5. So overall I am getting is 6, 8, this is 10 I think, yes 10, this one is 12, this one is 14, right? 12, 14, 16, 20, 24, 26. Find its mean, you will get 14.36. Just add it and divide it with number of observation. So are you observing something? This was 7.18 and this is 14.36. So 7.18 into 2 is 14.36. So in mean also it is multiplied by 2. If you will multiply every observation with 2, in mean also you have to multiply with the same number, that is 2. Got it? Just like addition and subtraction, if you are adding any fixed number to every observation, in mean also you have to add the same number. In the same way, for multiplication also this works. If you are multiplying with some numbers in all the observation, multiply in the mean also. That's it. How will you prove it? Same algebraic proof you can give, like x1 plus x2 plus xn. In a number of observation, its mean is a. Mean is given as a. Clear? If mean is a, what if I'll multiply with some scalar number? Let's say I have multiplied with 5 here. Okay, what about 5x1, 5x2, 5x1. What will be its mean? So obviously mean is 5x1 plus 5x2 plus dot 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 5xn divided by n. This is the overall mean. Yes sir, this is the overall mean. But if I'll take 5 common, so x1 plus x2 plus xn divided by n, right? And this was the mean of n observation, no? So 5 into a. So in mean also it is multiplied by 5. That's it. This is what I have to prove, no? So 5 was not a unique number. You can take any number like 6, 7, 10, 10 crores. Any numbers you can take. So this is 5 into a means basically k into a, where k belongs to any real. That's it. This was the proof for multiplying every value by a constant. The mean is also multiplied with the same constant. Okay, now let's move to the median part, and I don't need to explain this median, right? Median all of you knows. Middlemost values. The middle value is the median, right? And if you are getting two middle values, just take the average, that's it. For two middlemost values, just take the average, otherwise it will be a middlemost values. But the concept here is you have to arrange in ascending order. The data should be in ascending order. That's it. The data should be in ascending order. So see, observe here. This is 3 and this one is 5. So obviously this one will be 4. Yes sir, 4. This is 7. This one is 8, 9, 11, 13. What is the middlemost values? Middlemost values, this one is 4, 2, 4, 7. So two numbers. This is 11 and 13. So obviously the median will be the middlemost values, and that is 8. Because on left hand side we have two data, on right hand side we have two data. So the middle values is 8. So median is 8. That's it. Now same thing I am doing. I am inserting a number that is 11, and this value is obviously greater than the median, right? Because the median was 8. Median was 8 here, and I have inserted a value 11 which is greater than the median, and I am trying to observe what will be the overall effect on the median. So 8 values, this is the new number I have inserted. Sorry, this one is 8. Obviously this is the median, previous median we had, and I have inserted 11, right? 11. So earlier it was one data for 11. Now we will have two data for 11. What will be the middlemost values now? What will be the middlemost values? So now we have two middlemost values, right? 8 and 11. 8 and 11. Two values. So when you have two values, how will you find the median? Take the average. This is what I said, na? Take the average. So 8 plus 11. 8 plus 11 divided by 2 is 19 divided by 2, and that is 9.5. So its median will be 9.5. Median will be 9.5. Okay sir, this is fine. Median is 9.5. So means median increases or decreases? Median increases or decreases? Sir, it is increased, sir, because the previous median was 8, now it's 9.5. So it is increased by 1.5 here, right? After inserting a value which was greater than the median. So insert a value, see the rule. You have observed the result here. If you will insert a value greater than the median, overall median will increase, and this was the example for the first rule. Overall median is increased. If you will insert a value less than the median, Obviously the average value you will get lesser than the median. No? That's why the median decreases. You can create many examples. Okay, for second one also you can create. First one, so I have given one example to you, that if you will insert any value greater than the median will increase. If you will insert any value less than the median will decrease. Okay, that is fine. Enough discussion on this. Let's find out the missing weight. One example based on the mean median. Okay, Coach Balwan recorded 10 wrestlers' weight in kg. Okay, this is the example of NCRTs given in your book. One got smudged. Average is overall 19.2 kg. Okay, means one data is not given to you. One data is not given to you, and you have to find that weight. Yes, the word. You have to find that weight. This is what you have to do. 42, 40, 39, 33, 48, 38. This weight we have to find simply. So what is the average? Average means simply add all the values. You have to add 42 plus 40. This is very boring work to do, right? Adding all the numbers. 33 plus 48. But what you can do? You have to do it, no? 38 plus 42 plus 35 plus 42 plus 35 plus 32 plus this W. This is what you have to find, plus this W divided by total number of, see how many total wrestlers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to divide with 10, and this value is equals to 39.2 kg. It is given 39.2 kg. So one unknowns we have, right? One unknown, one equation, you can solve it. The weight you will get as 43 kg. Please solve it. This is very basic. The weight you will get equals to 43 kg. You have to add all this number. When you will add it, you will get, I think, 349. Yes, 349 you will get, plus W divided by 10. This is very simple. You can do it by yourself. Okay. So this was the example given in your NCRT. I hope this is clear to you. Was based on finding the mean. Okay. Let's do one more example, and that is a coconut harvesting example. So when Kaya's average harvesting per tree is given to you as 25.6. Okay, means per tree the harvesting average is given as 25.6. Now from 15 trees, okay, have overall 15 trees, one tree count was recorded 3 more than the actual. Actually the average, that overall average he has counted, no, that is not the actual mean he has counted. Fine, that is actually the wrong data. So simply how will you solve it? How will you solve it? How will you find it the actual mean? How will you find it? So see, simple, we have 25.6. 25.6 is given as the average harvesting per tree. Average harvesting per tree is 25.6. Okay, sir. Means average harvest per tree is given as 25.6. This is for one tree. What about the 15 tree? So basically you have to multiply it with 15, right? First of all, if you will multiply with 15, for one tree it is given 25.6. When you will multiply with 15, 25.6, you will get 384. 384, but this was not the this is not the actual mean. No, he had counted 3 more than the actual average harvesting. He has counted 3 more than. So instead of subtracting 3 to all the data, because the data is not given to us, Data is not given to us. So instead of adding these 3, you can actually subtract, instead of subtracting to all the data, you can actually subtract 3 from 384. This is the actual mean. I've told you now. If you are adding the same value to all the data, the mean will be affected by this number. If you are subtracting the same data to all the numbers, the mean will be affected by the same number. That's it. Okay, so 384 minus 3 is 381. This is the overall values you are getting. Okay, this is the overall values you are getting, 381. Now when you will divide it with 15, because this is not per trees, this is the overall for 15 trees. So per trees, if you want to find out 381 divide with 15, you will get 25 point something, like 25.4. That's it. This is what you have to do in this problem, because it is given that the record was 3 more than the actual number. That is not the actual number, it was 3 more than. So in mean, what you have to do? Subtract the 3, no? Subtract with 3. Instead of subtracting 3 to all the date observations, means data whatever given to you, but here data is not provided, right? So instead of subtracting to all the data, finally subtract with the mean, no? So 384, but the actual is 384 minus 3, that is 381, and this is for the overall trees. So per tree it is 381 divided by 15. That's it. So 25.4 is the final answer for this example. Fine. Now let's see one example where you have to find the mean and median. I'll not find it, you have to find. How will you find mean and median for this? Because all of you knows, whenever you are given a data and frequency, how you found the median and mean? For median, what we used to do? Cumulative frequency, right? Should I explain this? Cumulative frequency. For mean, what you used to do? One formula, summation of fi xi divided by summation of fi, right? This is what you have to do. So let me explain the concept. You will do it by yourself. See how? Frequency is given as 3, 11, 9, 7, 3, 1, 1 and 1. So 3, 11, 9, 7, 3, 1 and 1. This is frequency, right? So basically the number is given as xi. This is called xi. This is fi. So what was the formula? Summation of fi into xi. So basically you have to make a column here. If I'll raise this one, if I'll make one more column here, so this is for summation of fi into xi, right? Because the formula for mean is, okay, for mean I am finding, median you have to find it by yourself. Cumulative frequency, all of you know how to find it. Summation of fi xi divided by summation of fi, right? So what is fi xi? This is fi xi. Clear? Fi xi is 3 into 3, 9. 11 into 4, 44. Okay, let me fill this. 42, 21, 8, 9, 10. What is fi xi? Just add it. You can use the calculator here. If you add all fi xi, let me check it is correct or not. 3 into 3 is 9, 11 into 4, 44, 9 into 5, 45, 6 into 7, 42, 7 into 3, 7 into 3 is 21, 8 into 1 is 8, 9 into 1 is 9. Just add all these values. What are the values you are getting? Let me add it. What values you are getting? Wait. सर का तो कैलकुलेशन ही नहीं आता है. लेट मी ऐड देट. आता है बे, आता है. 9 plus 44 plus 45 plus 42 plus 21 plus 8 plus 9 plus 10, right? 188 you are getting. Please verify it. 188, and this is fi into xi. Fi into xi is 188. What is summation of fi? Means this one you have to find. This is summation of fi. 1 plus 1 plus 1, 3. Overall this is 3. 3 plus 3, 3 plus 10, 13. 13 plus 9. So 13 plus 9 is 22, 22, 23, 33, 34, 35, 36. 36 you are getting. Let me add it. Check it. Yes, 36 you are getting. So what is 188 divided by 36? Values you will get in point, right? So when you will divide with 9, it is 9 4 ja 36. 9, sorry, from 9 it will not be divisible, I think. Yes, from 9 it is not divisible. So let's divide with 4. Yes, by 4 it is divisible, I think. Yes, it is divisible by 4. So 4 9 ja 36. 4 9 ja 36, and it will be 4 4 ja 16 and 4 7 ja 28. So its value is approximately equals to 5.2, right? So the mean you are getting as mean value is, okay, so the mean value is 5.2, and how you are getting it? By using this formula, summation of fi xi divided by summation of fi. That's it. Median calculate by yourself. Find the cumulative frequency. I'll not do it. Median you have to find it by yourself. This is very simple, and I hope you have learned in the previous classes. Now let's see how you can study the line graph. First of all, we will see what is a line graph. Then we will look at how you can study the line graph and how it can help us. See, so a graph that is made up of connected line segment that is used to show the change across the time. This is all about the line graph. Basically, whenever you have to see the changes across time, no? Like in years, it may be possible that the times are given in years, and if you want to observe some quantity over the years, line graph is very useful for you. See how. You have given two states. One is the Kerala and the second one is a Punjab. Okay, and what you are trying to find, you are seeing the temperature over the years between the two states. So in blue color, if you will see, in blue color it is for Kerala, the graph of blue color is for Kerala, and the red one is for Punjab. So in the month of June, if you will observe, the temperature of Punjab is highest, right? In the month of June, see how you can read the graph. Basically, you are given two line graph, fine, for two states. Sir, from where data is coming, sir? So it is observed data. Data is observed, and this data you have created. Fine. I am explaining you how you can read this data. Clear? So in the month of June, the temperature of Punjab is the highest. So this is written here, a peak in June with a value around 38. So what is the value here? It is somewhere between 30 to 40, but this number is closer to 40, right? So this is about 38, right? So 38 is the peak temperature in the month of June for which state? For Punjab. Now observe this one. The month of July is the value, this is the lowest value for which state? Lowest value of temperature for Kerala. Means in the month of July, the temperature is at the lowest position for Kerala, and which is for the top position for Kerala. Okay, observe this one. I think this one is the top position for Kerala with the value about 32 approximately, 32 degrees Celsius in the month of April. Fine. So this is a way to read any line graph. So this is clear to you. If you will see, this is an upward slope between January and June corresponding to Punjab. Actually, what it's trying to say, no, from the month of April to month of October. Yes, observe this time, April to October. Generally, the temperature of Punjab is more than the temperature of Kerala. Can you observe this data? From April to October, see this one, because this line, red graph is above this blue graph, so its temperature is higher than the Kerala, because this blue color represents for Kerala, red one represents for Punjab. Okay, so April to October, this is basically the hot season for the Punjab. Okay, not for Kerala. If you will compare with Punjab. Okay, so this is how you can compare the two states. Okay, and this was a comparison based on the temperature, about the degree of hotness and coldness. You can also compare the degree of precipitation as well, right? So if you are reading any line graph, no, so simply you have to do the two steps. What are the two steps? First step is identify what is given. Means the overall data, try to identify it, that what we are comparing it. How is the graph organized? What does the axis show? Obviously the axis, like in this graph, the x-axis shows the month, right? The x-axis shows the month and the y-axis shows the temperature. This one, so you have to observe it, and everyone knows how to observe it, right? Second step, you have to see the peak values and the low values. That's it. You have to check for the peak values and the low values. Like here, I have told you, for the peak values was in the month of June for Punjab, and the peak values for Kerala was in the month of April in terms of temperature. This was the peak values. You can also find it for the lowest values. The lowest values for Kerala is July, the month of July. And for Punjab, can you see it for Punjab? Yes, January is the coldest month in Punjab. Yes, January is the coldest month in Punjab. So this is how you can compare between the two states. I think enough discussion for this topic, line graph, how you can read the line graph. Let's see for the rain also. One example I have given you, that, okay, three cities you have given, Kovalam, Udupi and Mumbai, and you are trying to observe the average rainfall in these three cities. Fine. You are trying to observe the overall rainfall for these three cities. So the red one basically denotes for the Udupi. This yellow color for Mumbai, and this blue color is for Kovalam. Okay, fine. For Kovalam. Wait.
చేస్తున్నారు వీడియో కాల్ చేస్తారా చూపిస్తాను డిస్ప్లే బ్రో ఎలా బ్రో
పవర్ పాయింట్ ఓపెన్ చేయండి.
పవర్ పాయింట్ ఓపెన్ करो एक बार చూడండి
ప్రెజెంటేషన్ చేయమన్నా.
ప్రెజెంటేషన్ ఇదే ఎక్కడ
కింద ఉంటుంది చూడు ప్రెజెంటేషన్.
రైట్ సైడ్ కదా
అది కాదు లాస్ట్ చూడు ప్రెజెంటేషన్ ఫుల్ స్క్రీన్ అదే. ఇప్పుడు డూప్లికేట్ డిస్ప్లే సెట్టింగ్ లో
డిస్ప్లే సెట్టింగ్
డూప్లికేట్ చేయి కింద. F8 నొక్కు. F8
F8
अभी एक्सटेंड करो.
एक्सटेंड
ओके अभी OBS में क्लिक करो. OBS ओपन करो. नीचे जो है OBS
ये ओपन करता हूं लास्ट में OBS
हाँ ओपन करो. अभी उसको बड़े स्क्रीन में ड्रैग करिए. స్పీడ్ లాగా అవుతుంది అప్పుడు
వచ్చింది రండి
తర్వాత ఫుల్ స్క్రీన్ చేసే
అంతేనా
అరే ఇదను అది డ్రైవ్ చేయొద్దు స్పీడ్ లాగు
రావట్లేదు అంతేనా
ఇటువైపు స్పీడ్ లాగు గట్టిగా ఇప్పుడు ఫుల్ స్క్రీన్ చేయి
తెలియదు
కంటిన్యూ చేయమన్నా
అప్పుడు తెలియదు
स्टॉप हुआ है क्या
అక్కడ రావట్లేదు సార్
ఏం రావట్లేదు
అక్కడ స్క్రీన్లో
అది అవుతుంది లైక్ చేయమని అవుతుంది వీడియో స్టక్ అయిందా
స్టక్ అయిపోయింది
వీడియో స్టక్ అయిందా సరే మన చూడు కెమెరాలో కేబుల్ ఉంటుంది వస్తున్నా
12.
Hey, hey, keep the live till here. I think most of the chapters I finished. Mostly. End the session. Stop. Stop. Okay, so in this graph, basically, it was given the monthly average rainfall for the three cities, that is Udupi, second one is for Mumbai, and the third one is for the Kovalam, right? So are you able to observe or read the graph? The previous graph I have explained it to you. So can you explain this graph for this one based on the previous graph, right? Can you explain this one? Yes or no? For this one, if you will observe, in the month of July, which city has the highest precipitation rate? A red one. For Udupi, the month of July is the highest chances for the rainfall, right? Because it is approximately 900. The value is 900. What y-axis represents here? The y-axis represents the average rainfall in millimeter. What x-axis represents here? The x-axis is basically the month, right? So we are trying to compare the three cities based on the month and the rainfall. So in the month of July, if you will observe, the month of July, Udupi has the higher chances for the rainfall. So this is the peak point for the Udupi city, right? For Mumbai, if you will see what is the peak month, obviously the July is the peak month for the rainfall as well for Mumbai also. What about the Kovalam? So if you will see in Kovalam, so this is for June, right? Yes, sir, for June, higher chances for the precipitation, right? Lowest chance, if you will observe, lowest chance for the yellow ones was basically for Mumbai. January there will be no rainfall, February, March, December, right? The chances of rainfall are very low. For the Kovalam, if you will see, January has the lowest chance of rainfall. And for the Udupi, if you can see, from January to April there will be low chance, and then again in December there will be low chance for the rainfall, right? So this was all about reading the line graph. Clear? So this is how you will compare the two cities, or more than two cities also. You can compare 3 cities, 4 cities. It depends on the number of line bar graph, right? Now we also have compared the 3 more cities, that is Rameswaram, Chennai and Puri, right? Rameswaram, Chennai and Puri. Let's observe the rainfall in these 3 cities. So if you'll observe the month of July, basically this violet color represents for the, this one is for Puri, right? I hope, yes, this one is for Puri, and this violet color is for Chennai. Yes, this one is for Chennai, and this blue color is for Rameswaram. Greenish color, Rameswaram. Now observe it. If you will see, the month of July has the highest chance of rainfall for the Puri, right? The month of July, highest chance of rainfall. What about the Rameswaram? Rameswaram, November has the highest chance. November has the highest chance for rainfall. About Chennai, see the peak values, that's it. Other than that, you can see the average value. Just try to see the peak values of any line biograph. Peak value means extreme values and the, yes, extreme values means the lowest value and the highest values, right? So for Chennai, what will be the highest chance? And it will be in November only, right? So in November, the Rameswaram and Chennai have higher chances for the rainfall, and in Puri, you will have highest chance in the month of July, right? So this is how you will read any graph. The previous was also for the rainfall only, and x-axis represents the month and y-axis represents the average rainfall. And this was for Kovalam, Udupi and Mumbai, and this is for 3 different cities, that is Rameswaram, Chennai and Puri. That's it. This is how you will compare the eastern side and the western side cities. Okay, fine. So with the help of bar graph, you can compare the 2 cities, 3 cities, 4 cities, 10 cities. Depends on the areas, like southern states you can compare, northern states, eastern state and western states, based on the temperature, rainfall, like that. Whatever the parameters you can choose by yourself. Clear? So this was the application for the line graph. That's it. So I hope this chapter is clear to you. I have discussed many things in this chapter. Please go through with this. And once again, go back to the index. Now I think everything is clear. So if you want more such sessions, please visit the SISYA class courses. We have booster course, math champ course, SISYA topper program going on. Just simply what you have to do, go to sisyaclass.com/LTC, tap on your grades, fill in your state name and mobile number, and that's it. You are good to go. So if you like this session, please subscribe to the SISYA class channel and share with your friends. We'll meet you soon in the next chapter. Thank you. Tata. Bye bye. Have a good day.